here we're going to look at the triad problems. So number one, describe the transformations of the parent function f of x equals x squared, and then graph the function. Part A, we have g of x is equal to negative negative x plus 2 squared. So we have a negative here, we have our plus 2, and then our k value would be outside here. There is no k value, right? It's just 0. So the negative, it's going to be a negative 1. So that tells me that this graph is going to, if we go down on our notes on the bottom here, negative 1 is less than 0. So that means it's going to open downward. The absolute value of negative 1 is 1. That tells me there's no stretch, no compression. So a stretch would be greater than 1, and a compression would be between 0 and 1. If it's equal to 1, there's no stretch, no compression. Now you don't need to state that. I just want to write that in there so we can kind of reference that, or be aware of that. Next we have our plus 2. All right, that's my h value. So since h we're adding 2, that means we're going to go to the left. So it's 2 units left. All right, that's where, again, our vertex would shift. Our whole graph is going to shift, but we'll use the vertex as a reference point. And then my k value, all right, the k value is just plus 0. So there's no shift up or down. Again, you don't need to write that there's no shift. We're just using that as our reference. So this would be our k value, and this is our h value. And then these two are a. So what's going to happen here, write this in black. So from our vertex, which is normally at 0, 0 for a parent function, we're going to go 2 units left. So I'm going to take the vertex from the origin, and I'm going to shift left 2 units. Now from here, I do need some other points, obviously. So what I'm going to do is I'm going to take the equation, negative 1 times x plus 2 squared, and I'm going to plug in negative 1. All right, and the reason I'm using negative 1 is because I do need something that's kind of in this range for part of my graph. And in the next section, we go into a lot more detail on how to figure out these points. We're just kind of doing this quickly here. We're more concerned about what the actual transformations will be, not so much how we're graphing them right now. So this is negative 1, 1 squared, which is negative 1 times 1, which is negative 1. So when x is negative 1, y is also negative 1. So we have that point there. So this tells me negative 1, negative 1. Now, there are other points that we could graph, but what I'm going to do is I'm going to mirror this to the other side of the vertex. So this point will also be over here. And now I have enough points to draw a very crude sketch, a very rough sketch of my graph. It opens downward, which it's supposed to. It was 2 units left, which is what was supposed to happen. And it didn't go up or down at all, and there was no stretch, no compression. So we're good there. In part B, we have a k value of 2. We have minus 1 as our h value. And then the a value out here, right? There's no a value, it's just a 1. So that actually helps us. So since a is positive, it's a 1, this is going to open upward. There's no stretch, no compression, because again, it is just 1. No stretch, no compression. The h value, so we have a minus 1 here. That tells me that it is going to go right 1 unit. And then for my k value, it's written as plus 2, so that tells me it's going to go up 2 units. So from the origin, I'm going to go right 1 and up 2. So that's going to be right there. So right 1, up 2. And then from here, again, I can pick something kind of near it. What I'm going to do is I'm going to use 0. All right, I want to figure out where the graph is along that line. So I'm going to take my equation, x minus 1 squared plus 2, and I'm going to plug in 0. All right, these are x values. You're looking along the x-axis. So I have negative 1 squared plus 2, which is just 1 plus 2, which is 3. So I have the point 0, 3. So I'm going to go up to right here. And again, I'm going to mirror that to the other side of the vertex, which would be to that right. And then I have enough points. I only need 3 points, as long as one's on each side of the vertex. And I've got a rough sketch of my function, which opens upward, no stretch, no compression. It went right and it went up, so things check out.